All right, we should be live. Those of you who are entering the room, say hi to us in the chat. We'll wait a second because I know it takes a delay for the video to get started for everyone. All right, I see Chad. Chad's in. Julian, Ralph. So welcome everybody. So hi, Bret.
Hi.
All right, let's.
We are go for internets.
We are go for internet. All right, All right, so we're working. Let me turn on. All right. So hello, everyone out there. We have a lot of people in the chat. I'm counting up to 92 people at the moment. First things first, you are more than welcome to chat during the entire session. I will be keeping an eye on the chat. And Bret will be doing what Bret does best, and that's just delivering tons of great information for us. If you have questions, here's what I'd like you to do. It's not the most intuitive design, but down where you type your message, there's a little ellipses, the three little dots that sit next to chat. There should be something down there that says ask a question. We have the questions separate from the regular chat, just for management. If you ask your questions there at the end of the session, we'll try to answer as many of them as we can, or as long as Bret can stay around with us. So that's the first housekeeping thing. Next housekeeping. Let me jump into my slides real fast. All right, so hit start. All right, so. Thank you, everyone, for coming. Those of you who don't know me, my name's Kevin Griffin. I am the owner of a company called SwiftKick, and we offer software training and consulting solutions to everyone around the globe who might need some learning or just a general level up in their career. It is a pleasure to have you all with us today, and this webinar series is just part of our effort to give back to the developers out there. I have grown up with developers and being in the community for 10 years now, and I give all my success to just being active in this awesome community that we have. So I'm hoping I can give back with these webinars, and I have great friends like Bret who come and they just drop knowledge for everyone. And a special thank you to Bret for joining us this week.
Glad to be here.
So, and if you need more information after this, we're going to give you tons of resources. So if you can't get what you need out of the resources that we provide, Bret in particular has a really awesome resource I want you to take a look at. Come talk to us at SwiftKick, because we offer additional training on top of this, mentoring services, all that good stuff. We would love to talk to you if you just need a little bit more help in this direction. Please give us some social media love. Who doesn't love Twitter or Facebook? And, you know, LinkedIn, that's another thing that's over there. There's different ways to reach out to SwiftKick on those different social media accounts. Please give us some love on social media. We would greatly appreciate it. As a reminder, this entire session is being recorded, and within a couple hours you should get a replay link. So if you ever need to go back and watch it again later, send a replay. If you are watching the replay right now, so we're talking to people a couple hours or a couple days in the future, you're watching this in the future. If you're in the future and you're watching this and it's not September 6th around 11 o'clock Eastern time, you can still ask questions. And what's awesome is those questions get emailed to us, and we can get you answers even though it's not the live show. There might be a little bit of a delay just because I got to get them to Bret, and Bret's got to think about it and then regurgitate some sort of knowledge. But you can still ask questions, and that's awesome. And most webinars don't let you do that.
If they're asking, if the people are asking in the future, are we answering in the past? Is that?
Well, we'll answer in the future. So
we'll answer in the future. Okay. The future. Not now, but in the future. Yeah. Okay. Yeah. Got it.
Since this is a webinar series, we always have webinars going on. You might have seen in the chat room, we have Mr. Chad Carter. He'll be with us in about 2 weeks, and he's going to talk about something related around HoloLens. That link will go out to folks in the next couple days because we're going to start promoting that. But that's September 20th at 2:00 p.m. So it's a solo Wednesday, but it's a little bit hour further ahead than this week. And then the week after that is Mr. Frank Lavinia. He hasn't given us a topic yet, but his focus right now is around data science. So if you're interested at all in big data, data science, that sort of thing, Frank is probably going to deliver something really cool. But you all will get an email on that, so you don't have to know right now. And also pay attention to Twitter, Facebook, LinkedIn, all that good stuff. And if you're interested in doing a webinar, and this is a community venture, if you're out there in the community and you want to give back some knowledge, or maybe you want to get started speaking, talk to us, because I would love to have folks out there who just want a place where they can practice a talk and get some feedback from the community. Send us an email, info@swiftkick.in. And without further ado, I'm just going to turn it over to Bret because he's the man, and I've learned a ton from Bret personally. I had this little snippet I was going to read about Bret. So let me read it. So for 20 years, Mr. Bret Fisher has built and operated systems from 4 machines to 4,000 machines and helped over 15,000 people learn dev and ops topics. He's a Docker captain and the author of the widely popular Docker Mastery series on Udemy, which I'm pretty sure a lot of our audience have started going through that course already. And if you are enjoying it, say something about it in the chat. Tell others who haven't signed up yet how awesome it is.
Or what you don't like.
Or what you don't like. Yeah, exactly.
It's not awesome.
He also provides DevOps style consulting and workshops on Docker and orchestration. Bret's an occasional shell, web, and JavaScript developer and spends his free time in Virginia's local thriving tech scene, helping others in leading meetups, which also I'm a part of. So,
which just like Kevin does.
That great community, just giving back. Bret basically spends his time helping people and giving high fives. So high five, Bret.
Internet high five.
He lives at the beach, writes at bretfisher.com, and tweets at Bret Fisher on Twitter. So with that said and done, Bret, it is all yours, sir.
This is where I get to talk?
You get to talk. I'm going to turn my face off, and I'm going to mute my mic, and we'll come back when you're done to do Q&A.
All right. And I might ask Kevin a question now and then, or he might pop in whenever he feels like it, because that's how we like to do it here in Virginia. Is we have fun. So Kevin and I, like you said, have been friends for a long time. We work together. We've partnered together on things, and he's just a really cool guy. So I like hanging with him, and I'm glad he's doing this. So we're going to start with the assumption that you are possibly semi-aware of Docker, but definitely new to Compose. And then we're going to hop around and show some examples. And obviously, we can't teach you in like an hour how to do everything in Compose and how to change your whole life. But I'm going to give you as many tips and tools and some examples. We're going to go through at least 3 or 4 examples and code and actually starting things up. And I'm going to share my screen, and then we're going to do some cool stuff. And let me actually share that now. Ooh, I think that works.
Yep, you're in.
Okay. So I have a directory. Yay. But we're not going to start there. We're going to start with the assumption that you don't have Docker and you don't have Compose. So a quick summary of how you make sure that you have the latest Docker. Because Docker is a cool technology that does a lot of things now. It's not just this thing that runs containers. It actually solves more problems as they continue to add features. So we need to make sure we have the right Docker and the latest Docker. So if you looked on my machine, I can actually do a Docker version. And because I'm on Edge, which is kind of like beta, I'm on 1707, and that means the year 2017 and the month 7, or when it was released. And we want to make sure that you have at least that. So you're going to go to store.docker.com. That's where you get most things Docker. Not everything, unfortunately, and I'll show you what to do about that. But Docker CE is the free version, the community edition, and you can get it there. So you have to have Docker to use Docker Compose, which is why if you're on a Mac, you're going to want to use the Docker from Mac, which is what I'll be using in this demo. And I can tell because I got this little sweet menu up at the top. And if you're on a Linux variant, you're going to look for that here. Fedora, CentOS, we've got Ubuntu, Debian. If you're on Windows, you have a couple of options. If you're on Windows 10, you'll see up here at the top, as long as you're on Windows 10 Professional and Enterprise, you get to use the cool new Docker for Windows that came out about a year ago. If you're on Windows 7, Windows 8, 8.1, or possibly Windows 10 Home Edition, you have to use the toolbox, which you can click here to go get, which will open up a different page and let you download the toolbox. Now, the toolbox actually comes with the latest version of Docker, but it doesn't have all the latest extra features that you might get on a Mac or latest version of Windows. And that includes things like this little drop down and the preferences screen, which gives me a nice little GUI for changing all the settings. So you don't get that in the toolbox, but you can do most of the Docker things that you'd want to do every day if you don't happen to have the latest version of Windows. Now, if you're on Linux, if you're on Linux, you don't get Compose as a part of this install. If you're on the toolbox or on Docker for Windows or Docker for Mac, you get the Compose command line. So how do I know? If I'm at the command line on my computer and I just type that, and if you're on a Windows computer, that's either you can use a Bash shell or you can use PowerShell. If you're on a Mac, you can use PowerShell. I'm sorry, you actually can use PowerShell, but you don't want to on Mac. Not for this. You want to use the default Bash, or you can use ZSH or Fish or any other shell, because it's just going to be a binary Docker Compose, right? So if I do the version command like I just did before for the Docker, I can see that I'm on 116. So you may not have exactly 116, but you definitely want to be on like a Compose 113, 114, 115, something new like that. Now, if you're on Linux and you're running Linux as your desktop, Compose does not come with the Docker install, right? So if you go to the store for Linux and you actually clicked on Fedora and follow the instructions for how to install it on Fedora, it's not going to get you Compose or Docker Machine, which is a separate tool we won't talk about today, but that's another cool tool. And so here's a quick little tip. If you're on Linux and you want to have the latest version of Compose, I always go over to github/docker/compose/releases. And we'll share those links later in a list. And Docker releases their Compose binaries in a nice even cadence on GitHub rather. You can also get them from Docker's documentation website, but sometimes it's a little outdated there because documentation doesn't always get updated as soon as things are released. So whenever I want the latest version of Compose for Linux, I come here and notice that this was just released 5 days ago. It's actually newer than the version I have. And it also tells you that if you're on Mac or Windows, you can get Compose with the Docker for Mac or Windows installs that you can click here, which will just take you to the store. So anyway, store for most things, GitHub if you're just getting Compose for Linux. And what you should have then is Docker Compose at your command line down here. Now, let's back up after that for a second. And maybe you're playing around, or maybe you're just watching and you're not actually doing anything. Maybe you're playing around and actually trying to get this stuff installed. Maybe you just want to watch and you'll do that stuff later. That's fine either way. So let's back up a minute and talk about Docker itself, right? Because if you're not that savvy on Docker, you may be wondering, why do I care about it as a developer tool? So even if your team is not using Docker for production or for testing, you yourself can actually use Docker just to make it simpler to set up your own developer environments, to create a MySQL server, for instance, or maybe you just need to run a PHP server and you maybe need 2 different versions and it's tough to fight between the different versions. Well, Compose makes it easier to do all of that. And really in the background, what Compose is doing is it's just hitting the Docker API on your machine and doing multiple Docker things all at the same time. And so Compose doesn't naturally do anything that Docker can't do. It just makes it easier, and usually it takes things that would maybe be 3 or 4 Docker commands, and it makes them a single command, and it's project-based. So a lot of the other tools nowadays, they put a .something file in the root of your project for whatever you're working on, and that tool will read its settings from that file. And Compose is very much like that. It uses a YAML file in your project directories, 1 per project, and you put all the settings you need in there for how to run your apps, how to maybe launch that MySQL server that you need just for that app you're developing, or maybe what version of PHP you need to run, or Node.js you need to run. So it can do a lot of those things in the background with really very simple commands that we'll see in a minute. So assuming that you're not using Docker already, then now that you have Docker installed and Compose installed, you could actually just type Docker commands to start things. So without getting too fancy with Docker or going into this whole deep dive of what Docker is, I could do something, let's see, I could do something like just run an Apache web server. So in my directory here, I could just do a Docker run. Actually, we're going to use the new way of doing it, Docker container run. And that does the same thing as a Docker run. If you've been around a while, you know that the command line has changed and that we now have Docker container run, which is, you can do shorthand for Docker run. But if I just did Docker container run HTTPD, that would run an Apache server. And how would I know that, right? How do I know that that's what it's doing? So that little last part of the command is actually the image I'm going to run. And if I just did Docker help, Docker run help, which by the way, the help is fantastic, I can get all the commands and stuff that I would type and all the options I would type here. And at the end, you'll see that I'm running an image. So an image is really just a program. And without getting too much into the whole image concept, the way that I always look up images and to see if there's something that I want to run is I go over to Docker Hub. And Docker Hub is basically like the apt-get of images or of Docker, or maybe it's the, if you're on Windows, it's the NuGet of the container world, where all the open source software and even some closed source software is available there for you to pull down. And for instance, if I just typed in HTTP, because I know on certain Linux variants that that is an Apache server, I can see the official Apache server here. I can look at all the settings that I need to set in order to run it. And you can look at that on your own. We're not going to spend much time on that, but it gives you some examples of how to run it. And if I was so inclined as a Docker person, I could run that right there. Now, in the background, that's downloading and actually starting an Apache server on my machine, but I can't use it because I haven't actually allowed a port to it. And so I'm going to have to do something like Docker container run, then do something called publish. So in Docker world, the ports of a machine and actually the IP of your container are not actually public until you publish them. So you can't even get to them from your local machine. So in this case, I'm going to say that port 8080 on my local machine is going to go to port 80 in the container because that's where Apache runs by default. And I'm going to do that. Now, if I went over my browser and just went to localhost 8080, you would see that my Apache server now works. And if I actually went over here, you could actually see that I'm hitting it. I can see the logs here on the web server. So great, I've got an Apache web server. But if you're a developer, this is just like the tip of the iceberg. Like you would probably be wanting to run a HTML website. Maybe you're running some sort of statically generated website, so you're just really working on HTML. Or maybe you're a front-end developer and you just need an Apache server so that you can work on CSS and HTML and that sort of stuff. Or maybe you're a PHP person and you're going to attach mod PHP to your Apache. regardless of all that, you're going to have to start doing more things at the command line here. And that's where the Docker command line starts to get a little tedious. So this is where I'm going to sell you on Compose. Because if I needed to say, take the files in my current directory and share them with the container inside the container, I would have to do something with a volume. And I have to do something here with a -v, and I might have to do something fancy like print my current working directory into here and type paths that I don't remember all the time. And then maybe I have to do a detach to get it out of my console. I mean, basically your Docker commands turn into shell scripts, right? Because they get really long and you don't remember what they need to be for this project because you're maybe working on a different project 10 minutes ago, and this one's got different commands. This is why we have Compose. Compose and the command line for it are designed to be the same repeatable workflows while all of the settings that we're just describing, the publishing of the ports, the mapping of a volume, the connecting of your SQL server to your web server, all those things are stored in the Compose file. So let's look at what that might look like. Let's go into a little sample directory I have. So I have a single small tiny index file that maybe I'm a front-end developer and I want to work on the HTML and I want to display it in my browser. And I want to run it through an Apache server. So I could do the same thing we were just doing from the command line inside a Docker Compose file with very simple YAML. And if you've never seen YAML before, it's actually very easy to use. It's pretty self-descriptive, really. The tabs matter, by the way. You can't use tabs. You got to use spaces, and they all have to be consistent. And you'll notice up the top, I have the version line that needs to be in every Compose file, and the most current version is 3.3. And for each application I want to run, maybe it's a SQL server, maybe it's Postgres, maybe it's Apache server, maybe it's Nginx. For any of those, they all need to be a service. So in this case, I'm just running one, and I called it web. And I'm going to use that same image we talked about that I'm pulling down from Docker Hub for Apache server. And then I'm going to tell it that take my port 8080 on my local machine, my Mac, and forward it into the container on port 80. And that way I can actually get to my web server. So all of that is really just saving us the time of running that big, long Docker command. And so now what I can do is I can do a Docker Compose, and I can just type up. And what up does, as you can see, is it actually creates a private little network just for my Compose file. And when I'm running here, it will run the container that I asked it to from the HTTPD. It'll actually make the container and the network, all these things named properly so they're scoped to my project. And the way that Compose thinks about a project is the current directory you're in is the root of the project. So you always want your Compose file at the root of the project, and then all of your subdirectories and whatnot are the rest of your repo. So you really, when you're doing like a Git repo, usually Docker Compose is in the root of that. So you'll notice that it stays running on my screen, and if I just hit a refresh, you'll know that the log starts to hit there, and I just keep refresh a couple of times. Yep. You'll see that? Okay, so easy peasy. Now, all I ever have to do when I want to start this project back up is do a Docker Compose up. If, for instance, I wanted to actually run it in the background instead of in the foreground so I can get my shell back, I can just do a -d, and it will run that in the background. And so now I can stay in my directory and work there, but you'll see in the background that it's still running. Now, Docker Compose actually has a couple dozen subcommands. Really, I only need to use 3 or 4, maybe 5 on a regular basis. And that's what makes this so great, is if you're working on multiple projects, the workflow of using Compose is the same, regardless of whether it's a Ruby project or a Node project, or you're just using a regular MySQL server with a front end on something like Python or something. So if I do a Docker Compose help, just like the Docker command line help is really good, this help is really good as well. So you can see all these different commands, and a lot of these commands are very similar to their Docker counterparts. But again, back in the background, Compose is just talking to Docker on my behalf, and doing all the fancy things without me having to know all those Docker commands. So in this case, I want to know is my, I want to know what's running in Docker Compose. So I can do a Docker Compose PS, and you'll see that it's actually showing me one container is currently running. And I can actually bring this whole project down, clean everything up, get rid of the containers, get rid of the network, because maybe I'm done for the day, or I'm going to go move to the next project that I'm going to work on, and I just do it down. And that gets rid of my container. It keeps the image. Maybe it built me a custom image, which we can talk about later, but it cleaned up the container, got rid of it. It killed the network, got rid of that. So it keeps things nice and tidy, right? That's nice. So great. Now let's talk about a little bit more advanced. So maybe your project is a little more advanced than that. Let's see. What are we going to do next? So, by the way, here's another tip. The compose file itself has lots of options, and we can't possibly get through all those today. The good news is Docker has great documentation on the compose file, and I am literally hitting this website on this particular web page itself probably 10 times a day when I'm working on compose projects, even after using compose for years, because it keeps changing, it keeps evolving. Old stuff still works, but new stuff keeps getting added. So you'll notice it talks about the versions, but over here on the right, all the different commands that I'm talking about today are all over here. So for example, the ports command, you can see over here that it talks about how to do that and all the different options you have in syntax. So it's it's quite verbose and gives you examples all along the way. So I keep this thing running. This is a tab that's constantly on my computer because I'm always needing to reference something that maybe I don't use very often. So don't think that you need to be a compose file expert to do that. So I'm in a new directory. I'm in a new project. There's nothing in here, but let's just look at the Docker Compose file. Okay, so this one has gotten a little bit more advanced, and we're going to start at the very top and go through it. The purpose of this project for me is a simple Drupal server that I will start locally with its own Postgres backend and allow me to play around with Drupal. Maybe I'm a theme editor or I'm customizing some Drupal modules, and I'm not wanting to spend all my time making a custom Drupal install. I just want to use the default one. So again, you'll see the version at the top. You'll see the Drupal here as a service, but you'll also notice down here that now I have the second service, the Postgres server. So these two containers are going to run side by side, and Compose will make sure that they can talk to each other. And the way that they can talk in the network and find each other is that their name in DNS is actually their service name. I don't need to do anything else. I don't need to add links. I don't need to add any special depends on or anything like that for them to simply communicate, because in Compose, everything in my Compose file can communicate on the same virtual network. So the nice thing is in my Drupal image, I can simply tell it the name of my database server is called Postgres, and it will automatically find that. You'll notice here that I'm specifying a specific version of Drupal, as well as the port that we did before. We're going to use the same port this time. And then I'm going to specify volumes. Now, volumes are a new concept that we haven't mentioned in this talk, but there's two types of volumes. There are volumes where we bind mount to the host, and that means if you have source code on your Mac or your Windows machine or your Linux, and you need to share that in the container. We discussed that in the while ago, where maybe I need to put that index file in there. And we're going to go back to that in a second. But here I've got named volumes. And what this really just means is I want it to save the data here so that when I recreate the containers later, that the data still exists on my machine. So anytime you need to save unique data, and this is unique data, this is data that you're creating like database files or custom themes, you don't need to just save anything because you can just recreate stuff from your Docker image, right? So I'm going to download this Drupal image, and I'm going to download the Postgres image, and then I'm going to create a password for my database server, and then I'm going to save my database files. So let's just do that. And again, I'm just going to do a Docker Compose up. And so in the background, it's pulling down those images, it's creating the network, it's creating the containers themselves, and it's starting them. And you'll see that each container now gets its own colored logs. And the Postgres server looks like it's already started, and the Drupal server looks like it's started. Notice you'll often see with Apache servers, by the way, in containers that they'll just complain about their host name and their domain name, but that's fine. They're just saying, I really don't know my name, so I'm just going to guess what my name is, and that's totally fine. So let's go back over to port 8080 and hit refresh, and now you'll see that the logs are starting to fill up over here. Right? I got 2 log entries in my Apache server. And now I get the Drupal install screen. So I could totally go through this and install a standard Drupal server with my own settings. The only little nuance that you need to remember, I'm picking Postgres, is that I need to worry about the defaults of Postgres. Like, what's the database name going to be? What's the username going to be? You're going to find all that back over on Hub. So remember, Hub is the place with all the documentation on the images we're using. And I know I'm using the Postgres image because that's what we specified in our compose file. So I'm going to go over to the Postgres page. And if I scroll through this page, I would read things like, you need to make sure that you specify a password, that the default username is going to be Postgres, that the default database is going to be Postgres. So it's going to answer all these questions for me. So I know those in there. And if you remember, right, if I was in this compose file, remember that I added a my password as a password. Then under advanced options, you'll see the host. Now the host defaults to localhost, but in container networking, we never use localhost because the localhost in a container is that container. And we don't want that. We want the Drupal server to talk to the database server. So let's do Postgres because that's what we call the service, right? So over here, the service name is Postgres. That's also the DNS name. So we're going to save and continue. And the way we know that that all worked is it'll actually start the install without an error, and that's how we know it connects. And you can actually see all the database stuff happening over on the left, along with a bunch of automation that is happening in the background. So that's Drupal. This isn't really a talking about Drupal or going in depth into Drupal, but it's a great example of a simple little setup with a 2-service compose file that I simply typed. Oops, didn't mean to do that. Simply typed Docker compose up. Now, if I want to do that in the background, I could do the same thing there, and it would go in the background. When I hit Control-C, it actually killed the compose and stopped those, but it didn't actually clean them up. So let's go back and clean them up again with the down. Now, the next thing is what if I have files on my machine, and I need to get those into the compose and into the containers when they run? Well, let's go back to our previous example. Super easy to do. So if I'm in here and I just add a new entry for volumes like we did before, I can say something like dot, which means the current directory of my files. And then I'm going to need to tell it where it's going to mount that in the container. Now, these are all manual things that I'd have to do with a Docker command line. But again, because we're in Compose, I'm going to save them in the Compose file. And it's going to make it so much easier. So I happen to look on the documentation website on Docker Hub. And I know that for Apache, in this case, I need to go into the user local Apache 2 htdocs directory for the default location of HTML files. I'm going to save that, and then I'm going to do a Docker compose up again. We'll do a D this time in the background. And the way we know that works is if I go back to my little 8080, I should get a custom, simple little HTML page because I am awesome at HTML. I know how to put a single line of text in an HTML file. Yay for me. Okay, this basically shows that the file that I have on my Mac, which if you look in this directory, there's a single index file. So if I just showed you what that looks like, it's just a simple little HTML file. So for a developer who's going to work on files on their machine, but they want them to run in the container, this bind mount is how you do that. And it's once you've figured that out and you've realized where you need to mount your directories into your apps, then you start to realize that this replaces Vagrant. This replaces having to use on a Mac. You won't maybe have to use Brew anymore, Homebrew, in order to install various versions of things, or to keep your PHP version up to date, or your Node files. You don't have to change your Node over all the time to different versions. You can actually do this in your compose files. You can specify the versions of things you need, and each time you start a project, you just do that Docker compose up. So if you can imagine your workflow on a daily basis, what this really comes down to is you're going to sit down on a computer, you're going to go into a directory where you have your repo, you're going to do your Docker compose up, and it's going to build and set up everything you need for that project. Then at the end of, you can run multiple projects at the same time. Like you could leave that directory, go somewhere else, and do a Docker compose up as well in there. It's not like you can't do multiple Docker compose ups and different projects at the same time. You just have to remember that published port, that 8080, can only be used by one container at a time that's running. So if I wanted to run a PHP app and a Node app in different repos at the same time, I would just need to make sure that one of them is running on 8080 and one's running on like 8081 or some other port. Otherwise, you're going to get a conflict. You'll get an error that says this port is already bound to something else. And this is just a nature of TCP/IP, is that a port can only be listened by one application. So the Docker is using that port and it can't use it again. So if you know about Swarm, or if you've ever heard of Swarm, it's like Kubernetes or Mesos or other orchestrators, and that Swarm is designed to take multiple machines and make them act like one. So if you're using a Docker compose file in development and you start adding more things to your compose file, then that compose file, if you're using Swarm, can actually now be used in production, or even in your testing stack, like maybe you're using Jenkins or CodeShip or something like that. You can actually use those compose files there as well. So the compose file is actually quite reusable. And another tip, if you are in a team, let's say you're in a team of many, and not everybody wants the same compose file. They maybe want slight changes. And that's where you do compose override. So if we go to, let's see, let me book Google real quick, and hopefully it's the first one. So there's this concept in compose of using multiple compose files, or using a standard override file. So anytime I want to change a setting, but I don't want in compose, but I don't want everyone else in my team to have to use that setting. Maybe it's a SSH key that you need to use an environment variable, or maybe it's a special password or path or something that you need to use. You can do that inside your directory with your compose file by just creating a docker-compose.override.yaml. And anything you put in there will override by default your default Docker compose file. So normally what I do is, if you're using Git, I will have it ignore override files so they never get written to the repo. And then Docker compose can be the defaults that everybody has agreed on and uses. And the override is what people will use on their own to customize their environment. You can actually look at this link, which talks about how to do that. And it talks about using the override file. You'll see that it actually mentions it right here. And you can actually use any file you want that's a YAML file in the compose format. And you just have to specify them if they're not the default name with a -f for -file. But I find it easiest to just use the standard override nomenclature, because then I don't have to specify anything. Compose on startup will automatically look for that file and apply it last in a layered approach on top of that default compose file. Now, you'll also notice in here that there's this concept of extends. but extends is a different way of using multiple compose files, and it doesn't actually work in Swarm yet, so I really don't recommend looking at extends. I really find that for most cases, just using this layered approach with the override file actually solves a lot of your problems. And that's also how you can use this same compose file if you're in a Jenkins job to do some testing and maybe run some test infrastructure, or to use that same file in production. You can just layer over different changes with different override files. All right, I'm going to take a break for a second, and if Kevin's around, let's see if we have any questions or anyone asking about things.
We do. We have a ton of questions.
Ton of questions.
They have been busy in the Q&A. So I'm going to work backwards because I think the questions at the top are more relevant to what you were just talking about.
Cool.
We had a lot of people put in like pre-fill questions at the beginning. So I'm going to work my way down.
Sure.
Hey, and actually, while we're answering questions, I'm going to throw up the link for Docker Mastery, which is Bret's extremely popular #1 course on Udemy. Let's see, and this should be popping up in your right sidebar right now, where you can go check it out. There's a couple preview videos, and it's at an extremely low price right now. And if you use our link, it actually helps spread out more than if you just were to randomly jump across it in Udemy. And
true.
Those of you are already in the course and you're loving it, tell friends, get more friends into it, because when there's good content, you should take care of the good people that make the good content. So just support things you like.
Thanks, Kevin. And if you are actually a user of that or a student of that course, I just wanted to throw in a little tidbit here. There's actually a few more lectures coming to that existing course. And then in the next couple of months, I'm going to be working hard on an actual completely new course that will complement that one. And it actually goes to the next level on focusing on Swarm and more production focused concerns. And you'll have to, in order to take that course, it'll need you to know all of the Docker basics and the Compose basics and what Swarm is and the sort of the stuff of that. So that's going to be coming. I don't really have an expectation for release date because these things they're complicated and they take a while, and it involves a whole team of people to help me get it done. Yep. So, but that stuff is coming. I get that question a lot actually in our chat channel for the course about when's, I love what you're doing, Bret. What's the next thing you're going to release? And that's really what I'm going to focus on. Is we're not quite done yet with that current course. It's got over, I think it's up to 8 hours now of content, but I think a little bit more is coming, and then we're going to start on something new. So hit me with some questions.
All right. So I'm going to, let's see, if I press this button, it should broadcast to the room. All right. So everyone sees what question that I'm asking. This is from Daniel. He asked about the Compose file. Is it only reusable in Swarm, or can it be reused or used with other orchestration tools like Kubernetes?
It depends. Every orchestrator is different. There is no agreed upon format yet in the industry for orchestrators to all consume the same files. However, on the Kubernetes side, and there's probably somebody in chat getting ready to type this because we probably got some Kubernetes fans in there. So Kubernetes actually started, they started before Swarm existed. So Kubernetes was out there in the wild. So they actually now have a converter that will convert your Compose file over to the Kubernetes format. And I am probably sure if I just Googled it.
When in doubt, Google.
Yep. It's always fun Googling random things live on the internet. So it might be called, yes, go from Docker Compose to Kubernetes. So the answer there is pretty much no, it doesn't use the exact same file, but there is a path. And that's one of the things I love about Swarm is that Docker is designing all the tools, whether it's Docker, Compose, or Swarm, to all consume the same file formats. The Docker file format, the Compose file format, the overrides, all those things are all designed to make it buttery smooth as a developer working from dev to test to prod. But if you're using another orchestrator, they totally work with the same images. The image standard is the same, but they're going to maybe use a different because they have different features, they're going to need to use a different compose file. So I don't actually know what Mesos uses or Nomad or any of the other ones out there, but Compose is a very popular developer format. So if you're using a different orchestrator than Kubernetes or Swarm, you can probably find someone who's made a converter to take from Compose into whatever that orchestrator is. So good question.
Awesome. All right, next. This one, I don't think this has a quick answer to it, but I'll ask it anyway. This is from Lars. They're running in Active Directory. Is there a way they can connect a SQL database to their Active Directory credentials within a container?
An AD, how can I get an AD credential from a container? Ooh, I've never done that. AD credential. So if you're in a container and you're on a Windows container, which we haven't talked about, but if you're doing Windows development, you can run Windows containers on a Windows Server 2016. And that question is, inside that container, how do I actually pass my AD credentials to the MySQL server? I think that's what you're asking. And the answer is, I don't know. I've never had to do that. Server 2016 only was released less than a year ago, and it is the only version that really you can use in any sort of production data center kind of place that actually runs Windows containers. And I've not had a lot of demand for it. So I think that what we're going to see is in the next few years, a lot more of the Windows developer world is going to jump onto the containers. In fact, we didn't even have the ability for a Docker Swarm on Windows to have two containers talk like until May, I think. So just a couple months ago. So it's a pretty bleeding edge question. Thank you for the challenge, and I totally failed.
All right, another Lars question as we're moving down the list. What about debugging code that's running in a container?
So all debugging is going to work as long as your debugger is meant to run on a port. If it requires something where they have to run together or some sort of socket connection that's not a TCP port connection, then I'm not sure how that's going to work. Honestly, with every language that I've looked at in every major coding tool or IDE, if I just Googled, debug Docker, I usually find a tutorial very quickly. I actually have one on Node. So for example, on Node with VS Code, so if you're someone who does Node.js development, one of the great editors for that is actually Visual Studio Code, and I can actually just show you that. So this is actually Visual Studio Code is like Atom. It's a simple editor, but it actually has an increasing amount of features to it that makes it feel more like an IDE, and it's totally free from Microsoft. And it happens to be a pretty good Node editor because it has a lot of features out of the box and has a lot of extensions, which you can install over here. You can actually see that I've installed the Docker one. But if I opened up this project, this is actually a sample project. We'll put this in the notes as well. This is a sample project I created for a good starting point for Node.js if you happen to be a Node.js developer. And one of the things I do in here is in the Docker Compose file, I make sure that the debug port is open. All right. So in Node, there's actually competing ports because there's an old debug and there's the new inspect. So in this case, I have the new inspect port open on my Compose service. I make sure that I'm running Node with whatever the command is that needs to happen to kick off the inspector. And then inside of my IDE, I am like in this one, for example, if I go in the debugging options, the way that Visual Studio Code does it is it has a JSON file that you configure your debugging, and they have a documentation. They have a good documentation on the internet that basically describes how to do that. So I actually have the old and new methods in here that show how to tell the editor to talk to the container, because really a container is just a binary running in a restricted space on your machine. It's not actually a virtual machine or anything complicated where it makes it hard. but it is considered, in the case of debugging, it's considered remote debugging. So whatever your tool is, I would say look up the remote debugging options, and you're almost always going to find something that's going to work with Docker. I know this happens to work with PHP Storm. If you do PHP Storm with remote debugging, you can do the same thing in their world. I don't know of anything for Java, but I'm pretty sure that I've seen a Java tutorial. So you probably just need to Google the one for Java. Just Java debugging Docker, basically. Anyway, great question. There's nothing. In other words, the short answer to that is there's nothing special. It's just remote debugging over TCP is the way to go usually. So
awesome. I'm just going to move down the list a little. This one's, I'm sorry, I'm going to butcher your name. Akshar. His question is there a way to add synchronous wait for a service to be in a ready state before starting the next service?
Okay. So
I have
2 answers.
Okay.
What's that?
So I guess if I have dependencies, service A depends on service B.
Yes. So the first answer is going to be the it's not really the answer. But what it is it's when we start having this problem, the first concept I want to make sure whenever I'm talking to someone about this problem of application dependencies is that Docker is designed for the new world of distributed applications. That's really it doesn't have to be used that way. You can use it with legacy applications. But it really, especially when you come to orchestration, like when you talk about container orchestration, like Swarm and Kubernetes, that's all assuming distributed applications. And one of the core principles of a distributed application is that things can't depend on others to start. And that means that you're living in a world of the cloud and you can't guarantee that the database is going to be available. Maybe the network's down, maybe the server's rebooting, whatever, maybe there's too many connections and it's being overrun. So the different parts of your application, if you're able to develop them, need to be designed internally to handle that. And that maybe is that they have some sort of wait state for a connection. I don't really recommend that out of the box because that is a legacy. That's a sort of a hacky way to do it. I really recommend that you look at sort of the distributed application model for whatever software you're developing and how do I have retries that is for my connections. Maybe if I'm hitting an API, I have a retry event that happens so many times before it fails. So that's the political answer of you really want to focus on a distributed application. But if you are dealing with legacy apps that you just can't recode them, you can't make all that work, and basically what's going to happen is if you start the web server and the database isn't available, the web server just crashes. I still have 2 answers for you. And the first answer is, let's go over here. The first answer is in Docker and in a compose file, by default, it doesn't restart the container. But if you know that it's simply a second or two because you did a Docker compose up, and a Docker compose up does not control start order. Docker compose does not, it has a feature called depends on, but depends on, remember that location where there was all the compose features? So if I do depends on, there's a feature called depends on, but do not be fooled by that feature. That feature is not to guarantee that the database server is ready and available for connections in order for the web server to connect to it, right? Depends on is about making sure containers start in a certain order, but that's mostly for when I'm doing Docker compose up. So let's go over in this directory. Let's say I have a Docker compose up file that has 10 services in it. I can do an up, and then I name the service that I want to come up. Maybe that's just Postgres, and I want it to start up in the background. And it's only going to start that service. If I had 10 services and I was developing on one of them, and I didn't want all of them to start, but I did need the dependencies of that one service to start as well, that's one of the reasons you would use depends on. Depends on makes sure that if I start the web API, but maybe I don't need the web front end, that the web API knows that it just depending on the database, and the database will start in addition to it. The other reason is for DNS, because when you do lookups of DNS, let's say you're on an Nginx server, and an Nginx server is looking up your database. If it can't resolve the DNS, it gives you an error and says, I don't know, this doesn't work, I'm going to just die. All right? So the way you kind of go around that stuff is you'd use the retry. So the retry by default, I'm sorry, restart. Okay, so in a compose file, you can add the restart. So by default, in a compose file, restart is no. Now, we're really just talking about local development and testing. We're not talking about Swarm or production. So here, if you just simply say restart on failure, then what will happen is when you're doing local development, if that web server happens to start a little too quicker than the database does, which is often the case, as long as you have the depends on in there, because that's the friendly way to make sure that it knows to start both things, and then you have the restart policy of on failure, what will basically happen is the web server will just restart. And maybe it restarts 3 or 4 times. Totally fine. That's not going to kill the CPU on your machine, or at least it shouldn't, and it's not going to run you out of resources because it's just going to restart the application over and over. And that'll happen 3 or 4 times as everything's coming up, and then it's good, right? Then the database is ready, the web server's got the connection, and all's fine. The way longer answer to this question is about wait scripts. So I think it's called wait for. There's several competing scripts out there and options, and Docker even talks about this in one of their documentation files that talks about for legacy applications only, that you're not trying to do distributed applications, then you can add a wait for it script, but these are really just scripts, right? So these aren't going to solve all the problems of startup, but for a legacy application where you don't want it to restart, you just want it to wait for the initial connection, then you can do something like a wait for it script. They give you a pretty quick example here of just how to do it in Bash. There's actually other programs out there that people have created to basically what you do is you start that application instead of your application in the container, and then it will start your application for you when it's ready based on some connection string or some other value. I'm not a huge fan of them unless I've just tried all the other options and nothing else works, and this is only the last resort. So great question. I get that question a lot, and sorry for the long answer, but it does have a lot of little pieces to it. So
it is kind of a different way of thinking. If you've been a developer for 10, 15, even 20 years, it's a completely different way of thinking of how to architecture our systems. And I can understand. It was like this for me, is just changing my thinking of how does all the little arrows and the boxes and the cylinders all point to each other.
Yeah. Once you get to like your 5th or 6th service in your compose file and you're distributing them all and you have multiple replicas of each container, if you're still dealing with wait for its and other things, then like the whole thing becomes really intermittent and hard to troubleshoot. And that's probably not his case. Like that may not have been the case of the question, and maybe they just needed a simple legacy app that was going to run on one machine and they needed to wait for it. And that's fine. But yeah, it's like those distributed apps, you really need each part of the application to be able to survive any intermittent stuff for anything, because the internet is the internet and it sucks. So things go down.
So kind of on the same lines, this will be the last question today. And this is from Titus. And Titus wants to know, I'm looking for a way to connect a few microservices together for a distributed scripting platform. A couple worker nodes, an auth service, and a monitoring service. The question is, how do I tell the nodes where to find each other? The auth service must be known to all the other nodes, and the monitor service must be known to the worker nodes. So they all just need to talk, but they need to know how and where to find each other.
That's a great question. And that is a part of that service discovery. It's probably something you've looked into already. Service discovery is a sort of a new problem that was created by orchestrators. So once we started using things like dynamic groups of servers that spin up and down on Amazon or we started considering orchestrators even before containers, these things that were spinning up stuff and tearing it down, we realized that we can't just type in an IP address and hard code something in, right? We need a place to go and find out where all of our stuff's at, basically. And that changes constantly. So the term service discovery was sort of the common term for how we solve this problem. In the past, that service discovery has been usually a key value store that each application had to go and look up. So you basically had to write your applications around service discovery to know how to find other things via a lookup. Maybe that was an API in front of the key value, or maybe they just talked directly to the key value. But in Swarm, and Swarm is really my expertise, right? So I focus on the Docker tool set. Unfortunately, I don't have the knowledge of all the orchestrators because they all do it differently. They all have slightly different service discovery. So in the Swarm world, it's really done through DNS. So it's all built in automatically. If you have, let's say you talked about this auth service. So if you have an auth running as a Docker Swarm service, then that is automatically load balanced if there's more than one replica. And I'm assuming this is a stateless service. So because, in the world of many different systems all needing awareness of each other, you really want it to be stateless, because stateful, as much as possible, because stateful, when things are dynamically moving around and they're stateful, that can be a lot harder than if they're stateless. So step one is hopefully that they're stateless, and that's the easiest way to do it. So if we're talking about something like a web API for your auth, for example, and you have maybe 3 replicas of that, 3 containers running, then in Swarm, you have a load balancer in front of that that's automatically, it gives you the single IP, but you should never use IPs because they're fixed. And with that IP, it's the name of that service. So if we go back to our compose file, just in my silly little example here, right? If I just look at that Docker compose file, then if this was an actual API service, any other service in my Swarm in this particular compose file would automatically be able to find that by just looking up Drupal. And basically, it's Swarm's job to make sure that the DNS name for that service always resolves to the load balancer for that service's containers, which can be one or more replicas or containers. It's the same term basically in Swarm land. And so those replicas are basically load balanced in a round robin fashion, right? And if I have a single, if this file right here was a microservice-based infrastructure, and I had 10 services, and one was API, and one was auth, and one was users, and one was whatever, other various little microservices, right? They're all, what I would usually have is for each one of them, I have an environment variable that is the name of what each service is that it needs to be. In other words, I would just say like host Drupal here, host, auth, host API, host whatever the other ones are. And then the name of the service that I have in this file would be the actual would be the name that it uses. So in other words, the API gets to the auth by just looking up the DNS name auth. The auth looks up the API by just looking up the DNS name API. And the rest is magic. I mean, it's not obviously magic, but it automatically removes containers and adds containers as you specify. And regardless of what nodes they're on, they're all transparent over an overlay network that looks like one subnet, basically, in all of your nodes of Swarm. And it basically just solves the problem. It's such an easy problem that I can actually get developers to start doing microservice-like architecture, or at least distributed services architecture, in a single compose file, and they don't even realize all the magic of the networking and the DNS and the load balancing, because they just know that services find each other based on their names, and they don't really have to care where any of it's at. The great part of that is that same compose file that I'm developing on locally with all those distributed services is the same file for the most part that can be used in production. I just need to maybe run more of them in production. And the way that they all route to each other through the DNS naming and load balancing all works the same way, whether it's on one machine with Docker running locally using Compose, or a 100-node swarm in the cloud using gigantic machines and having heavy load with thousands of connections a second? Great question. Hopefully I answered it.
I think you did. That was awesome. So we'll go ahead and cut it off there. We've gone a little bit over the hour, but I would like to first thank you, Bret, for hanging out with us for the hour. And I hope everyone out there got tons of amazing information out of this. It was, I swear, every time I sit down with Bret to talk Docker, he teaches me something new. I didn't know we were up to version 3.3 of the Docker Compose file until today. I was still using version 2. So I got to go update some files now.
Yeah. So much good stuff in that 3.3.
Yeah. That's why we have people like Bret to keep us up to date on everything.
We can't all know everything.
Yes. So Bret, again, how do people get in contact with you if they have questions after the fact?
So you can get a hold of me at my website, and I'll actually just put this on the screen since I'm already sharing. Actually, is that going to work? No, mark that. Boy, this is failing. There we go. So basically, you can get me at bretfisher.com, and that'll give you all the links to the Udemy course. There's actually the button in this webpage will get you a special link for the course. So in this webinar, that'll get you a link. But also, you can get on my newsletter there. You get my Twitter there and all the other socials. For Docker, we're going to send out a list of all of the links used in this and all the references to the documentation and things that I listed. But if you want to download Docker right now, you go to store.docker.com. If you're interested in being in the Slack community for Docker, you can actually go to Docker with no E .ly/community, and that'll actually sign you up for the community Slack, which is run by Docker themselves. And that is a really good place to like ask questions if you're not an IRC person or a forums person, which there's forums.docker.com, and there's Docker's everywhere. So you can get a hold of me though at bretfisher.com.
Awesome. And we will send all that information out in a follow-up email. I'll collect all the resources from Bret that he has, and I'll make sure I follow up with everyone. And this replay should be available within, should get an email at least within the next 24 hours from the webinar service that tells you where to go get it. And if you have any questions, you can just ask the question in the replay, and it'll get emailed to us, and I'll make sure that Bret gets it.
Cool.
But thank you again, everyone, and hopefully I'll see you all again in 2 weeks with Mr. Chad Carter talking about HoloLens.
Nice.
Augmented reality.
Thanks, and I'll talk to everybody later.